In the previous class, we've been studying about collisions, right?
Yes, sir.
And we have studied some important conclusions. We have understood what is a coefficient of restitution. Also, we have studied how a collision occurs. How momentum is conserved in collisions. Why? Because there is a transfer of momentum due to internal force, not external force. So if internal force, that means that means there will not be any external force. If external force is not there along the line of collision, we understood how momentum will remain constant. P initial is equal to P final.
Yes, sir.
Then P initial, from there we have derived things related to how momentum is conserved. And types of collisions we have seen. Elastic, inelastic, perfectly inelastic.
Yes, sir.
Can you, did I share the screen?
Yes, sir.
Then we have seen head-on collision. And we have found out formulas for final velocities of different balls after they collide with each other elastically head-on. Then one important conclusion, 5-star conclusion we have seen. For a head-on collision,
Perfectly elastic and identical masses. Only then velocities will get exchanged.
after collision, we have seen one
Yes,
derivation.
sir.
We have seen one problem also.
Hmm.
Then also, then will be there is maximum possible of kinetic energy loss. So it will lose when it is perfectly inelastic collision. When equal to,
Yes, sir.
then we have derived the formula for that also. Then we'll see some other important conclusions. Here, in this given situation, I took these two balls, right? M1, M2. M1 is going with U1 velocity, like this M2 is going with U2 velocity. And we derived formulas, right? For head
Yes,
of
sir.
collisions. Here I'll ask you one thing. In head-on collision, elastic collision, then masses are not identical. Okay. But M1 is much higher than M2. Okay. What will be V1 velocity one? That means velocity of the M1 mass after collision. What is velocity V2? That is velocity of the M2 after collision. Can you solve with them for me?
1 minute, sir.
You just try solving them. It's one another important conclusion. This conclusion. We know the formula is V1 vector is equal to M1 minus M2 into M1 plus M2 into U1 vector plus 2M2 U2 vector divided by.
M1 plus M2.
Here I consider M1 is much higher than M2, right?
Yes, sir.
M1 is much higher than M2 means here can I neglect
It'll be,
M2 and I can neglect this
yes, sir.
M2 also to some extent. If I neglect, what will happen? M1 is much higher means this denominator will be, I can write it as, instead of here I can write
M1.
it as M1 by M1, right? Into U1 vector. sorry, V1 is nothing but what? M2 minus M1, right? Or M1 minus M2?
Yes.
So M1 minus M2 only. So M1 by M1 plus 2M2 divided by
By M.
M1, which is very
Yes.
big, right? Then I can neglect this. I can
Okay, then here only I got doubt, sir. I thought I should not do it in this way.
right, this conclusion you can remember. V1 is equal to U1 vector. That means the bigger mass here, the bigger mass, velocity will not change. It will remain as the initial velocity only. Even after
Actually,
the
I did
tell me.
I did this, so I got it till here, sir. 2m2 by m. But then I did not think it will be 0, so I proceeded it in this way. In elastic, E is equal to V2 minus V1 by U2 minus U1. That is equal to 0 no. So I thought V2 is equal to
Oh,
V1.
that is equal to 1 elastic. V2 minus
Okay,
U1 minus U2 is equal to 1 elastic collision.
I have written it wrong. Fine.
Perfectly inelastic, that is 0. So here the answer will be V1 vector is U1 vector. That means velocity of that bigger mass will not change after collision. Very high, very big mass will not change after collision. Similarly, what is V2? V2 vector, if that is velocity of the smaller mass after collision, what will happen? M2 minus M1 by M1 plus M2 into U1 vector, U2 vector plus 2M1 U1 vector by M1 plus M2 vector. Here we can write it as this M2 can be neglected. The answer will be 2M1 by M1. M1, M1 cancel. This will become as 2U1 vector, right?
Yes, sir.
This one, M1 will be very bigger. M2 can be neglected here. M2 can be neglected here. Then you will get what? U1 vector, right?
Minus U. Where U1?
Minus U2 vector.
Yes, sir. Minus U2.
So the answer will be V2 vector is equal to 2U1 vector minus U2 vector. Okay.
Understood, sir.
Similarly, you can derive conclusions for this. These are the two velocities. If M2 is much bigger than M1, means V2 will be is equal to U2. That means M2's velocities will not change even after collision. That is, velocity of the second body will be equal to the velocity of the second body before collision. Velocity of the second body after collision is equal to velocity of the second body before collision. And the other one is what?
2U1
V1
minus
vector is equal to 2U2 vector minus U1 vector.
2U1 vector minus U2 vector, sir.
2U2 vector minus U1 vector. Similar to this. This is 2U1 minus U2.
Okay.
M2 is bigger, right? Same approximations you will do in formula, but you will get this.
Understood.
Okay. Then there are some other important conclusions. For the same situation, if that is like second case only, M2 is much greater than M1, okay? But there is a coefficient of restitution E. That means it is not perfectly elastic collision, okay? What happens? Again, write the formulas there, like V2 is equal to M2 minus EM1 divided by M1 plus M2 into U2 vector plus 2, sorry, not 2, 1 plus E into M1 U1 by M1 plus M2. If we substitute here M2 is much higher. That means we can neglect this. This can become 0. V2 is again U2. This conclusion. The bigger mass now also will go with the same velocity like in the previous situation. Okay.
Understood, sir.
But this will change. V1 is equal to. Here we got, what did we get the answer? 2U2 minus U1, right?
Yes, sir.
In case of 2U2, if we substitute, you will get 1 plus E. E is equal to 1 you substitute for head-on elastic collision. You will get the same answer. So 1 plus E U2 minus U1 vector. Similar situation. Then we will see some other. 3 kg ball moving at 10 meter per second. 3 kg ball moving at 10 meter per second collides head-on inelastically. Collides head-on inelastic. Okay. Inelastically with another ball of mass 2 kg. Matlab perfectly inelastic. Okay. You take it as perfectly inelastic. Now, perfectly inelastic. Another ball. In which collision? Another ball with another ball moving with of 2 kg mass, moving towards the first ball with velocity 20 meter per second. 20 meter per second. That means perfectly head-on, perfectly inelastic means what? They will go both together with the same velocity, right? Common velocity. They'll stick along the line of collision here. That means find the amount of perfectly inelastic collision. Find the amount of total energy loss. Similar to yesterday's some question I discussed. Total energy loss in this collision. Okay. You can try this question. You see this question here. The solution is, if you see the solution, first thing is momentum will be conserved. If you want to write, okay. Perfectly inelastic means E is equal to 0, right?
Yes, sir.
If you see here, so both will have same velocity, right? After how can we find that? M1 U1 vector plus M2 U2 vector initial momentum is equal to final momentum.
V1 plus
M1 plus M2 into V vector, right?
Yes, sir.
This is what we solved in the previous question. Momentum will be conserved. P initial is equal to P final. Otherwise, you apply the formulas also, you'll get the same answer. What will you get here? M1 U1 vector plus M2 U2 vector by M1 plus M2 is equal to V vector. That is actually center of mass also same formula you'll get. That is equal to M1 is 3 kg into 10 meter per second minus plus 2 kg into minus 20 meter per second.
Yes, sir.
By 5, that is 30 minus 40 minus 10 by 5, that is minus 2 meter per second. Minus 2 meter per second means they will go in the left side direction. That's what it means together. So now, what is the initial kinetic energy? Half into M1, that is 3 into U1 square, that is 100 plus half into 2 into M2. What is that? 20, that is 400. That means if you apply 300 plus 600, 300 plus 800 by 2, 1100 by 2. 1100 by 2 means what? 550 joules.
Sir, why did you get plus, sir, there?
Kinetic energy. Kinetic energy is a scalar quantity.
Oh, shit.
You cannot take minus there.
I've done partial mistake.
Kinetic energy you need to add. That's okay. Kinetic energy, whichever direction it may be moving, it will be positive only.
Yes, sir.
Kinetic energy final will be half into 5 into, both will be moving with the same velocity, that is 2 minus 2 meter per second, that is 2 meter 4 10 joules. Then loss is how much? Kinetic energy final minus kinetic energy initial. Otherwise, kinetic energy initial minus kinetic energy final is the loss. That is 550 joules minus 10 joules is actually 540
40.
is the loss of kinetic energy in this question.
Understood.
Yesterday also I told you this last formula, half m1 m2 by m1 plus m2, that v square, v center of mass square. You will get the
Yes.
so half into same concept derived there. M1 is 2, M3 is sorry, M1 is how much? 3 and 2. So 3, 2 divided by 5 into v square is 4. This is a 2 cancel. 3 4 is 12 by 5. Why did I get wrong here? Perfectly elastic collision that I solved yesterday.
1 second, sir. I'll tell.
So in this case, whatever it may be,
You told in this case only, sir.
no, this actually is at rest here.
Okay.
But still, that means this formula we cannot apply directly. This situation it got into half into mm into u square by m1 m plus m. U square, u is what here? Initial velocity of this body.
Yes, sir. Half,
It does not have any relation then particularly. Okay.
Okay.
This is, but this is the formula for reduced mass.
Sure.
This you cannot apply. Got it?
Yes, sir.
There only one body is moving, other body is at rest. But in spring cases, you can use that reduced mass concept.
Yes, sir.
Now, shall we go into some other questions?
Yes, sir.
Oblique collision. What is this? Oblique collision. In oblique collision, what do you know about oblique collision?
I know it's something. Yes, sir. In the last class, you told that even when two bodies hit, there is no need that they should be in the same line of impact.
There doesn't need it that they have to go in the direction of line of impact only. So now the 2 points here. Line of collision. Line of collision, you need to understand. What is line of collision? A line along which colliding objects apply forces on each other. That is normal reaction. That's what we are saying. Force on each other during the process of collision. you see two bodies here, like this, if they collide exactly, then the line of collision is exactly normal reaction, exactly
Yes, sir.
this one. Okay. Suppose initially the velocities are also like this, u1 and u2. This is called as head-on collision. It means initial velocity directions along the line of collision. Okay. Now, if you see, there is a situation of this sort. The body is coming and colliding the surface like this. So when it touches the surface, the force will act in this line, right?
Yes, sir.
But the velocity is coming in this direction, right?
Yes, sir.
This is called as line of collision. These two lines are equal. Are they equal?
No.
No. This is called as. Yesterday I showed you the example of oblique collision in carom board.
Carrom board. I was about to tell that only actually.
Suppose another body is going like this, some other body is going like this. After some time they collide like this, okay? But the directions initially are in direction they like this, but now the line of collision is this one, right? Okay. This is also a type of oblique collision. Carom board also I told you. If there is a coin of this sort, it is coming like this, if it strikes it. It comes in contact like this. The line of collision is this, but the direction of this coins are not along this line of collision, right?
Yes, sir.
The initial velocities are not along the line of collision. This is called as oblique collision. Now, how do you solve these oblique collisions? Okay. First, after collision, first step is draw the line of collision, okay? First step is draw the line of collision. Second step is, there are initial velocities, right?
Yes, sir.
Of two balls, whatever they're colliding. To resolve this initial velocities of the balls or colliding objects in two ways. One way is parallel to the line of collision, and other way is perpendicular to the line of collision. Then third point is solve parallel to the line of collision like in head-on collision. You got it?
Yes, sir.
How you solve generally head-on collision? In the similar way, you will solve parallel to the line of collision, whatever velocities is there, you will take them and you will solve according to the head-on collision, whatever the concept that you have learned in head-on collision. So like that you will solve.
Yes, sir.
And what will you do? Velocities of perpendicular. Because in perpendicular direction, there is no forces, right?
Yes, sir.
Only collision. Suppose if this collision is happening in this direction, suppose like this when the bodies are, I do an example for you. So now line of collision is this one, right? Now
Yes,
you
sir.
can resolve these velocities along this, whatever the velocity is there, along this line of collision like this, and perpendicular to the line of collision like this, okay?
Okay.
And this velocity also you can resolve along this line of collision like this, and perpendicular to the line of like this, okay? Now this is like head-on collision, right? This part.
Yes, sir.
So you solve this velocity, you take it as two balls approaching each other head on in a elastic or inelastic. Okay, head on collision. But these velocities, there is a force here to change both of them that we considered when we derived the formulas for head on collision. But is there any force actually changing these velocities?
No.
Right. There's no particular force acting here perpendicular to this normal component. So that is
Yes.
this velocity will remain same. These velocities will remain.
Same.
That's it. You can solve the problem. Okay.
Yes, sir.
Can we solve some problems on this?
Yes, sir.
On elastic and also on head on also and oblique collisions also. Okay. Some questions. Just I'll try to. Now in this material, this bouncing of ball question. Okay. Let a ball from height h and let it touch the ground with a velocity v, making time t to reach the ground. Okay. Let v1, v2, v3 be the velocities immediately after first, second, third collisions with the ground. Velocity immediately after nth rebound. Okay. If nth rebound, if you know first rebound, second rebound also you can calculate. Yeah?
Yes, sir.
This situation. So if the ball is here, the ball is here. Now, what will be the velocity when the ball reaches here? V is equal to root 2gh.
Yes, sir.
Do you accept this? If it is falling from a height h, then what is the velocity of the just freely falling body? V is equal to root 2gh.
Yes, sir.
Now, this is the initial velocity of the ball when before collision colliding with this surface. Okay.
Yes, sir.
Now, if it is elastic collision, what will happen? There is no loss of any energy. Right? Elastic collision, there is no loss of any energy.
Yes, sir.
Again, the ball will bound and it will go to the same height.
Okay.
You don't need to worry about it. Why, if you want to apply the concept also, in elastic collision, what will happen?
It will
Wait. I equal masses means exchange will happen, but they are not equal masses. If you apply the formulas, you see here, when the other second body is very large, here it's like very large, very strong, it will not move, right?
Yes, sir.
M2 is very, very, very large. At that time, what are the formulas? You tell me.
1 second. Then V2 is equal to U2 and V1 is equal to 2U2 minus U1.
V2 is U2 means here this surface is the bigger mass. So that surface velocity initially at rest, finally also will be at rest, right?
Yes, sir.
Then V1 is
2U2 minus U1.
2U2 minus U1 vector. Okay. U2 is again 0. Initial
Zero.
surface is 0.
V1 is equal to minus U1.
Minus U1 means what? Exactly whatever velocity it hit root TJH. After responding, minus means it will reverse the direction, but it will have the same velocity and magnitude root TJH. That means it will go to the same height. Did you understand this concept?
Understood, sir.
But here we will solve the question for inelastic collision. That means there will be some E. If E is equal to 0, what will happen? Perfectly inelastic, the ball will come and stick to the surface. But that's it.
Yes, sir.
Head on way. Are you understanding whatever I'm teaching here?
Yes, sir, I understood.
Now the second step is the ball will have coefficient of restitution as E. That case we will solve here. In our required situation, what we can do? E can be substituted as 1 if it is perfectly elastic. E can be substituted as 0 if it is perfectly inelastic.
Elastic.
And get the solve problems. If it is inelastic, that means between perfectly elastic and perfectly inelastic, the ball will go to some height which is lower than h1, and again next time the ball will go to some other height which is lower than h1. Again h3 will be lower than h2, like that. It will keep on going. Okay.
Yes, sir, I understood.
So now let me Can I erase this?
Yeah.
Let me solve this. So we what we have studied, bigger case, very bigger case. When E formula, what is that? V2 is equal to U2. Bigger one will remain same. But what will happen if you solve the problem? V1 is equal to 2U2, not 2U2.
1 minute.
1 plus EU2, that's what we were doing. Oh. 1 plus
1 plus E into M1 by M1 plus M2 U1.
1 plus EU2.
V1 is M1 minus EM2 by M1 plus M2 into U1 plus M2 into 1
One
plus
is
U.
what? 1 M1 minus EM2, right?
Yes, sir.
By M1
Yes.
plus M2 into U1 vector plus 1 plus E M.
M2 U2 by M1 plus M2.
One thing we know, U2 is 0 here. This will become.
Yes. Yes, sir.
Now M2 is very bigger here, I told you.
Okay. M2 is very bigger.
M1, if you neglect, what will happen? Tell me. This can be written as V1 vector is equal to minus
U1.
EM2 by M2 into U1.
Yes, sir. Okay, is so it'll be minus EU1.
V1 is equal to what?
Minus EU1.
Minus EU1. Simply from this formula also you can do V2 minus V1 by
U2 minus U1 is
is
equal
equal
to
to E.
1.
U2 is 0 here. That
Okay.
means EU1 is equal to V2 is again 0.
Yes, sir.
So V1 is equal to how much? Minus EU1 or not?
Yes, sir. Understood.
Here what is minus EU1?
Okay, in the reverse direction.
Reverse direction, the velocity will be. So minus EU1, right?
Yes, sir. That is what I said.
So this is opposite direction. Opposite direction, the velocity will be EV. If V is root 2gh, then V1 will be how much? In opposite direction, that is E1, EV. That is E into how much? Root 2gh, right?
Yes, sir.
Like that, V2 will be how much? E into V1, right?
Yes, sir.
That is V2 is equal to E into EV.
Okay.
That is E square V, right?
Yes, sir.
So like that, V3 is equal to E cube V. V4 is equal to E power 4 V. So after fourth collision, E power 4 V will be the velocity. That is E power 4 into V is nothing but root 2gh, right? If h.
Yes, sir.
That
Understood.
means that is equal to E power n root 2gh is the value if h is given. In this way, you can solve these questions. E power n root 2gh. Did you understand?
Yes, sir.
Like that, height also you can find easily, right? E power 2 and h will become height.
Okay.
Similarly, if you apply the concepts here, I'll send you this PDF.
Yes, sir.
Are you understanding?
Yes, sir.
V1 is EV, that is root 2gh1. Because after EV velocity, the height it will go only to root 2gh1, right?
Yes, sir.
First one is height h, second one is h1, third one is h2, like that.
Understood, sir.
So that is E into root 2gh. That is h1 is equal to E square h. That h2 is equal to E power 4h. h3 is equal to E power 6h. That is hn is equal to after nth rebound height it will go, it is E power 2n into h. In the similar way, time also you can get. Time is equal to root 2 h by g.
Yes, sir.
That means T1 is equal to root over, if you apply, E into T1. E into T. T2 is equal to E square into T1. Got it? T3 is equal to, because we have to apply root, right? T is equal to root over 2h by g. If you apply h, in the case of h, we can apply as e power 2n. E power 2n root is 2 cancel, e power n. Third rebound time will be, after third rebound, what is the time taken? T3 will be
E cube T2.
E cube T2, like that. Time taken in nth rebound. So then these are the formulas you can apply. Then total time taken also you can apply like this. T plus 2 T1, because collision first time will be time T, that is root 2 GH. Second one will be while going upwards root 2 GH1, while going downwards root 2 GH1. That is 2 times of T1.
Understood, sir.
Like I'll show you. This is T, then this will be T1 till here, that is e power 1 into T. Then this will be again T1, right?
Yes, sir.
After the T2 and
Yes.
T2, that is 2T2, right?
Understood, sir.
Like that, if you keep on adding using mathematical theorem, T plus 2T1, that is 2ET plus 2E square T plus 2E cube T, like that. 2T, if you take common, E plus E square plus E cube, so on. So 2T, you know this formula, right? A by 1 minus R.
Sir.
Geometric progression,
Yes, sir.
some terms.
Definitely.
E by 1 minus R is E here. If you apply this one, you will get it as
Yes.
T, if you take common 1 plus E by 1 minus E, root 2 H by G. That is main time T into 1 plus E by 1 minus E. So these are some of the years where advanced questions are asked, but sometimes directly mains questions are also maybe asked just
Yes.
on this thing. That's why I sent you this PDF. Okay. If some questions are asked, you can use them. These are some of the standard conclusions.
Yes, sir.
Nth rebound, after what is the time taken for nth rebound? What is the maximum, after 8th rebound, what is the maximum height it will reach? So what is the total time taken for colliding all the collisions? Like that questions may be asked.
Understood, sir.
Then oblique collision I taught you, right, till now.
Yes, sir.
There is some important concept in oblique collision. In oblique collision also, shall we solve one problem of this sort? Find the speed after collision and direction of motion. Okay. Like that, there is a ball which is coming with a speed u. It is colliding with the surface with an angle theta. Then what is the speed of this ball after collision? Okay. Direction also. Suppose if you see it like this, it is going.
So where did you draw this, sir?
Huh?
Where did you draw it?
Okay, you cannot see the screen, right?
Yes, sir.
Can you see now?
Yes, sir.
The ball is there. This is a ground surface. A ball is coming with a speed u and an inclination theta like this. So now the ball will rebound, right, like this.
Yes, sir.
I'm considering it as alpha, because if there is some E, perfectly elastic means what will happen? This is also theta, this is also theta.
Yes, sir.
But in elastic collision, we are not sure which direction it will go, what is the speed. So now the velocity in this direction is, suppose consider V. You need to find out what is V. Suppose E will be given to you. In formula, you can use E, right?
Yes, sir.
What is V and what is alpha? Okay. Theta is given to you, U is given to you. Shall I help you out in this formula problem?
Yes, sir.
Now, if we draw the diagram here again, first thing it will collide like this, right? It will come and collide. This is the line of collision, right? Even if it touches like this, even it is coming like this, but line of collision is what? Wherever the force is exerting, right? Normal to the surface only forces will exert. So this will be the line of collision. Okay. In this direction, U is coming, speed. This is theta. That means this is theta. This is 90 minus theta and this is 90 minus theta. Okay. Okay.
Yes, sir.
Now you see, what did I tell you? First point, line of collision you draw. I drew the line of collision. Second point, what did I tell you? Two velocities will be there.
Parallel and perpendicular to yellow, sir.
Derive this parallel and perpendicular. Parallel to this means what? This is U means parallel to the line of collision means what? U cos of 90 minus theta, that is U sin theta, right?
Yes, sir.
Parallel to the line of collision is U cos of 90 minus theta, U sin theta. Perpendicular to the collision is U sin of 90 minus theta, that is U cos theta, right?
Yes, sir.
Now what did I say? Perpendicular component will remain same. Like that, wall also you can derive, but wall is at rest. Even if I resolve also, they are zeros, right?
Yes, sir.
Now this U cos theta will remain without changing anything. Nothing can be changed. But this U sin theta, we can apply the concept of what? Head-on collisions, right?
Yes, sir.
Solve the problem for head-on collision along the line of collision, and then perpendicular to the line of collision, the velocities will remain same, isn't it?
Yes, sir.
Okay. Now this is U sin theta. That means it is like, can we treat this problem like this? The ball is coming and hitting exactly perpendicular to the surface with velocity how much? U sin theta, right?
Theta, yes.
Then this is wall, that is bigger mass. It is at rest. So then what is the rebound velocity? Tell me. V is equal to, in opposite direction it will be there. EU, right? You remember? EU.
Yes.
No?
I remember, sir.
The previous question that we solved. That means in this question, what will become? This will be EU sin theta, right?
Yes, sir.
Do you understand?
Understood, sir.
Then the minus EU sin theta, that is opposite to the direction it is coming. So then the velocities will be how much? Perpendicularly upward it is going. That is EU sin theta. Then U sin theta, this one. So the resultant will be like this, right?
Under root of it'll be U.
Under root of U sin theta whole square.
EU, sir.
U sin theta whole square.
Okay. Oh,
U cos theta whole square. U cos theta whole square. Because the ball will have two velocities. One is perpendicular, one is parallel. Parallel one will change. Perpendicular one will remain same. Perpendicular one U cos theta whole square. Parallel one is U sin theta whole square. Got it? After collision. Yes. Then what will be the magnitude? U square.
U under root of V square sin
brought outside. Root over
E square sin square theta plus cos square theta.
E square sin square theta plus
cos square.
You check here. If you keep E as 1 here, E as 1, that means what will happen? Sin square theta plus cos square theta is 1. That means the magnitude will be how much? U. With whatever it hit, again it will have the same speed.
Yes, sir.
But E is 0 if you substitute. E0 means what will happen?
Cos theta.
U cos theta. That means only this velocity will be there, which is perpendicular to the line of collision. Parallel component will become 0 only because it is at rest. That will also come on. Hello, Ujjwala?
I'm here, sir. Can you hear?
E is 0, perfectly inelastic collision. Then U cos theta will be the speed. That means this velocity will remain. This velocity will become 0. Are you understanding?
Yes, sir.
Because along the head-on collision, both of them will acquire the same velocity. I told you, if you would have remembered, perfect
Yes.
velocity. That means this ball will not have any perpendicular, that is, will not have any velocity along the line of collision. It will also come to rest like wall.
Yes, sir.
Ball will go like this. Perfectly elastic collision, if it strikes like this, the ball will go like this. Okay.
Understood, sir.
Along the line of collision, the velocities will be same, right? Here, this wall also 0, ball also 0. Are you feeling comfortable here?
Yes, sir.
Comfortable in the comfortable with these concepts? They might be a little bit tricky, but I hope you are finding it clear. Then angle, I asked you to find the direction also, right? Angle means if I consider this as alpha, that's what I told you, right? Alpha,
Yes, sir.
the speed is like this in this direction. Tan alpha is equal to how much? Tan alpha is equal to opposite side, that is EU sin theta divided by
U cos theta.
U cos theta. That is U cancel. That means nothing but what?
E tan theta.
Tan alpha is equal to E tan theta. That is nothing but alpha is equal to tan inverse of E tan theta, right?
Theta. Yes, sir.
If you see E equal to 1 means alpha is equal to theta. E is equal to 0 means alpha is equal to 0 again. That means directly it will go like this. Ball. Perfectly inelastic condition.
Yes, sir.
So one of the year this question is asked also. In mains or advanced, I don't remember. Tan alpha by tan theta is equal to E. One of the year.
Understood.
Otherwise, tan theta is equal to 1 by E tan alpha. I don't remember the exact question, but something based on this angle. Okay. Okay.
Yes, sir.
Then, shall we solve some other questions?
We'll do it tomorrow, sir, because it is already late.
Okay.